Hello, welcome back. The title of this lesson is Solving Two-Step Equations Part 1. So in previous lessons, we've learned how to solve single-step equations. We either add or subtract or multiply or divide to isolate the variable and solve those equations. But here it's not going to be possible to do it in one step. We're going to need two steps. And we're going to need to combine, addition and multiplication or dividing and subtraction, things like that together. So let me just show you what the first equation looks like. It is 2 multiplied by some unknown x. Actually, let's change this instead of x. You'll see why in a second. 2 times some unknown t, and then we're going to add 2 at 3, and that's equal to 5. Now, here the equations are starting to look a little more complex. Remember, I told you in the beginning, you might be able to guess the answer to the equation, and that's great, but that is not the point. And this is where we start to see that. Many people watching this can still guess the answer and the value of t. But by the end of the lesson, it's going to be difficult for you to do that in your mind because there's going to be negative numbers and it's going to be difficult for you to calculate it in your mind. So you have to know how to do these steps. All right. Now, before we actually solve this, what could an equation like this mean? I want to give you a practical something in your mind, right? So I don't have an actual thing written down here, so I'll wing it. But this is basically an example, right? You're having some rabbits, a rabbit start a race from a starting line, right? He's running, right? And the rabbit starts 3 meters past the starting line. So here's the starting line, or I guess I could draw the starting line. Here's the starting line, or the 0 point. This is where we start running, right? And you have some rabbit, but he does not start here. He starts at the 3 meter mark, right? And he runs. I don't know how to draw a rabbit. That's a rabbit. It's terrible, right? I told you I can't draw anything. That's a rabbit. Believe it or not, that is a rabbit. He starts 3 meters from the starting line, and he is running this direction. And he runs at 2 meters per second. At 2 meters per second. So his velocity is 2 meters per second that way. And he runs for so many seconds. I don't know how many seconds. It's t seconds. But he stops way down here at the 5 meter mark. This is the finish line. So my question to you is, how many seconds did he run for? That's the question. So he doesn't start at 0. He starts at 3 meters past the starting line. He runs for some number of seconds, and then he gets to the finish line, which is 5 meters away from his starting position. So this equation is what governs that. What it says is, if you think about it, is he's running at 2 meters per second. That's what this is. And you multiply by however many seconds he runs for. This is going to give you how far he runs, because it's speed times time, meters per second times seconds. And whatever you get from that, you add 3 to it because he started 3 meters away from the starting point. And when you do all of that stuff, the race is over when he's 5 meters away from the starting line. So what value of t must work here? So how do you do this? Let's rewrite it, and we're going to solve it correctly, and then I'm going to show you how to avoid problems. If you have 2 times t plus 3 is equal to 5. We have to do this in steps. We have 2t plus 3. We want to get t by itself. We cannot do it in one step because we're multiplying by 2, but then we're also adding 3. So we have to you need to think about that variable being inside of a box, which is inside of another box. And we have to unwrap the outer layer, grab the inner box, and then unwrap the inner box and grab the value of t, right? But the problem is t is wrapped up in an inner box here, but then it's in an outer box with addition. So the way we want to tackle this is we want to first undo the addition by subtraction. We do the opposite, right? But if we do it here, we have to do it to the other side. Remember, I told you for equations, you can do anything you want as long as you do it to both sides. Here, I choose to subtract 3. Why do I do that? Because I know that 3 minus 3 is 0 and it'll disappear. So what will be left on the left side of the equation? Just 2 times t. What will be left on the right side of the equation? 5 minus 3 is 2. Now, if I gave you this equation, you know how to solve that because we just solved it in the last lesson. Let's solve it. 2t is equal to 2. We're multiplying by 2, right? So to undo that multiplication, we're going to divide by 2 on both sides. And we know when we divide like this, the 2's are going to cancel. We've done that many times in the last lesson. We only have a t left over. 2 divided by 2 is 1. And what are we solving for? Time. 1 second. So what this is telling us is if you have a rabbit, right, which is starting 3 meters past the starting line, and if he runs at 2 meters per second for only 1 second, then that means he's only going to go another 2 meters, right? The 2 meters that he runs plus the 3 meters that he started with means he's going to end up 5 meters away. And that's what you put in here. 1 goes in here, 2 times 1 is 2, 2 plus 3 is 5. The value of t, the only value of t that works is if the rabbit runs for 1 second, right? So these equations we're going to write down, they can all have physical meaning. We're not going to talk about the physical meaning for all of them because I need you to focus on how to do it, how to solve them. And the way we solve them is to unwrap that box. We have an outer box and an inner box. We have to unwrap that outer box by getting rid of the 3 that's kind of like hanging off to the side. Then we have a much simpler equation that we can then solve in another step. So we do one step and then we do another step. Now let me show you probably the biggest question that students ask when we solve this kind of equation for the first time. Here's the biggest question people will ask. 2t plus 3 is equal to 5. Most students know that you are going to have to get rid of the 3 and get rid of the 2, but instead of subtracting the 3 first, what they will try to do is they'll try to divide by 2. So they'll try to do something like this, divide by 2 or something, or divide by 2. But that's not going to work because when you divide an equation, when I say you have to do both sides of an equation, at the same operation to both sides, if you divide by 2 first, you can't just divide this by 2. You have to divide the entire left-hand side by 2. Now let me ask you, you can do this. There's nothing wrong with dividing by 2, the entire side. But when you are done with it, what can you do? How can you simplify this? Because you can't cancel the 2's. I know you want to, but if you remember back, we never ever allowed you to cancel things that were linked with a plus sign in the numerator like that. We always said that if you have like 2 times x divided by, or even 2 times x times y divided by 2, where everything's multiplied in the numerator or in the denominator, that anything common you could cancel. The 2's can cancel, the x's can cancel. But it's because everything is multiplied in the top and the bottom. Here you have a plus sign. So pluses and minus signs are going to make it impossible to cancel by multiplication and division in one step the way you're trying to do it. You are allowed to divide by 2, yes, but once you do it, it doesn't let you cancel anything because you're not allowed to strike through unless things are multiplied like this. So the proper way to do it, I want to just make sure everybody knows this is not the way to attack this, right? The way you do it is you first get rid of what's kind of hanging off. Like this is what you want, but this is hanging off to the side. You get rid of that first. Then when you have a simpler equation, then you do it in the next step the way that we know how to do it. And that's why we learn how to solve the single step problems first, because all you have to do is 2 of those in sequence. Now let's conquer the next problem. I think as you see more of these, it will become much, much more obvious how to attack it. 3 times c minus 4 is equal to 2. Let me rewrite it. 3 times c minus 4 is equal to 2. Now, some students might look at this and say, well, I'm multiplying by 3, so I want to divide by 3. But if you divide by 3, you have to divide the entire left side. The whole thing has to be on a fraction bar with a 3 on the bottom, but then you can't cancel anything. It's the same problem as before. So what you really have to focus on is, this is what I want. This is like the inner present. This is hanging off. I want to get rid of that first. I'm going to get rid of that by adding 4, and I'll do that to both sides because I know that that's going to work. I've done that before. See, if you ever feel like you're like inventing new rules, then just stop because you probably are inventing new rules. Here, we're not inventing anything new. We know that we can add 4, and we know this is going to make 0. Negative 4 plus this positive 4 is 0, so we know we're going to have a 3 times c left over, and we know we're going to have a 6 on the right. And we know how to solve this, so now we know what to do. 3 times c is equal to 6. We undo this multiplication by dividing by 3, and this looks like what we've done before. So we have confidence we're doing it right. 3's will cancel. And then notice how everything's multiplied in the top, so we can cancel these 3's. We have a single c left over. 6 divided by 3 is 2, and this is the final answer. Check yourself. Put it in there. 3 times 2 is 6. Because from order of operations, we do multiplication first before subtraction. So 6 minus 4 is 2, and that means this is the right answer. Same as we put 1 in here. 2 times 1 is 2, plus 3 is 5, so we know that this is the right answer. So in general, when you're doing things that involve multiplying and adding and so on, usually you're going to do the addition or subtraction first before the multiplication. All right, let's take a look at 5 times z plus 2 is 12. So let's rewrite it. 5z plus 2 is 12. What do you think you're going to do first? Well, you're definitely not going to divide. You're not going to divide by 5 because then you have to divide the whole left side by 5 and nothing will cancel. Instead, we're going to get rid of the 2. Subtract 2. Do the opposite. Do it to the right-hand side. 2 minus 2 is 0, so all I have left is 5 times z. 12 minus 2 is 10. So I rewrite this. 5z is equal to 10. And what am I going to do? I'm going to divide now by 5 to undo the multiplying by 5. Right? And because this looks just like what we've done before, I know the 5s will cancel and I'm not making anything up. I'm not doing anything weird. Z will be left over. And 10 divided by 5 is 2. Now check yourself. Put the 2 in there. Well, we'll multiply first. 5 times 2 is 10, plus 2 more is 12. And you get the right answer. Now, for some of these, you can definitely guess the correct answer. I'm not saying that you can't, but as we get a little bit farther into this, it gets a little bit harder to figure out what the right answer is just by looking at it. J over 6 plus the number 1 is equal to 3. This is a good example of that. So this is a little harder to guess. I know that some of you watching this can still guess the correct value of J, but it gets a little harder. You have to guess multiple J values, and you're basically guessing and checking. It's hard to look at this and see what you have to use for the value of J. And as we get more complex, it'll get even more difficult. So let's rewrite it here. J divided by 6 plus 1 is equal to 3. So let's do it the right way, and then I'm going to show you the wrong way to avoid. We're adding 1. It's like this is the inner present, the inner box. We're going to do that later. We're going to get rid of the easy thing first. We're going to subtract 1. We know we can do that. So you always look for what you can do first. And we know that 1 minus 1 is 0, so we're going to be left with J over 6. And that's going to be equal to 3 minus 1 is 2. Okay, so what I'm going to do is continue my solution over here. I'm going to rewrite it. J over 6 is equal to 2. All I did was rewrite it. So here I'm dividing by 6. How do we undo that division? We already covered that in the last lesson. We multiply by 6, and we multiply by 6 on this other side. And we can think of it as 6 over 1 to help us visualize that we're going to cross-cancel these 6's. So what we end up doing is we only have a single J left over, and it's 2 times 6, which is 12. And this is the final answer. J is 12. Check your answer. Put a value of 12 in there. 12 divided by 6 is 2. And then this 2 plus 1 is 3. So it gets more and more difficult to figure out what value is going to work by guessing. We have to do it the proper way to get the right answer, but then you can check your work. Now let me rewrite it really quickly and show you what not to do. All right? Much like before, if we have J over 6 plus 1 is equal to 3. All right, you see the thing is we have a J and we're dividing it by 6, and then we're taking whatever we get there and we're adding 1 to it. Let me give myself a little more room over here. And we have a 3 here. So a lot of students, instead of getting rid of the 1 first, they'll say, oh, I'm dividing by 6. So I'm going to multiply by 6. I'm going to multiply by 6 right here, and then I'm going to multiply by 6 right here. I'm going to do the multiplication first, because then I'm going to cancel the 6's. But you can't do that, because when you multiply, much like before, when I told you when you divided both sides, you have to divide the entire thing. If I multiply both sides by 6, I'm multiplying the entire left-hand side by 6. So you can't just put it there and cancel the 6's. You have to take the entirety of what is on the left-hand side and multiply the whole thing by 6. So you kind of have to add these parentheses here to show that you're not just multiplying this one little term times 6, you're multiplying everything times 6. So, of course, you could distribute the 6 in. You could still make some progress this way, but most students will not do that. They will just take off these parentheses, put a dot right here, and just think that you can cancel the 6's, but you can't do that, because if you do it this way, you're only multiplying by the first term, and you're forgetting that you have to also multiply by that other term. So my advice to you is don't do it like that. When you have a two-step equation, just look for the easiest thing to do first, the thing that makes it simplest, the fastest. And that usually is going to be to either add or subtract first. All right, it depends on the problem. I'm not going to say always do that, but usually that's what you will do. Now, we have W divided by 2 minus 1 is equal to 1. Now, some students might say, I'll multiply by 2, but you can't really just do that only to this term. You have to multiply the whole left-hand side by 2, which makes it uglier and not nearly as friendly. So we'll just we'll rewrite the problem, and we'll say, well, what is the easiest thing I can do? I like things that are easy, so I'm just going to get rid of the 1. I'm going to add 1. I'm going to do the opposite. And I know that negative 1 plus 1 is 0, so it'll drop away, and I'll have W divided by 2 is equal to 2. And now it looks like an equation I already know how to solve. So I'll rewrite it. W over 2 is equal to 2. And I'm dividing by 2. I'll undo it by multiplying by 2 on both sides. And I can think of this as 2 over 1. And I'm cross-canceling fractions. The 2's will then cancel. I will have a single w left, and 2 times 2 is 4, and that is the final answer. Now check your work. Put a 4 in here. 4 divided by 2 is 2, and this 2 will be minus 1, which is 1. It is difficult to look at this equation ahead of time and figure out what value goes in there, because none of us are human calculators. I mean, I'm not. Maybe you are. But most people are not a human calculator. So do not try to solve these in your head. In fact, a lot of students get really frustrated that they can't look at the answer and just like look at the equation and just get the answer. Trust me, I look at these and I can't get the answer. And I doubt many people can. And that is okay because we are not human calculators. Let's take a look at a different one. What about 3 plus 2 times h is equal to 11? Again, some students will try to divide by 2, but if you do that, you have to divide the whole left-hand side by 2, which looks ugly. So instead, we're going to get rid of this 3 first. We're going to, we'll do it like this. We'll say 3 plus 2h is equal to 11. All right, and so I have a 3 here. I'm going to get rid of it. This is a positive 3, right? There's a positive, invisible positive in front. I'm going to subtract 3 from both sides, which means I have a 0 right here. 3 minus 3 is 0. I'm only going to have a 2h left over, and 11 minus 3 is 8, like this. Now, let me rewrite this. 2h is equal to 8. What do I do to get rid of the 2, which is right next to my variable? I divide by 2. I do the opposite. And I know that these 2's will then cancel, and so I'll have a variable h left over. 8 divided by 4 is, 8 divided by 2 is 4, and you get an answer of 4. You can check it by putting 4 in here. 2 times 4 is 8. And then 3 plus this 8 is indeed 11, so h is the correct and final answer. All right. All right, I think we can squeeze another problem in right here. What about 5 minus x is equal to 9? All right, so I know that I want x. I don't see a number in front, but I know that the easiest thing to do is to get rid of the 5 first. So let's go ahead and say 5 minus x equal 9. So I can push things apart and space things out, right? And I can like insert in between here, instead of, this is a positive 5, I can subtract 5 from both sides. Because this is a positive 5, so to get rid of it, I'm going to subtract. And I'm going to do it, I'm going to insert it right in between them, because remember, when you add or subtract things, when addition, you can rearrange how things are added without changing anything. So I could put a minus 5 at the end, and then move it over here, but instead I'm just going to write it right next to it. As long as I put the minus 5 in and the minus 5 in, it's okay. Now, 5 minus 5 is 0, but you still have a negative x here. That's a little bit different. Negative x. 9 minus 5 is 4. You have a negative sign here. Don't forget that that's there. Now, how do you get x by itself? What this means is negative 1 times x. So let me rewrite this. Negative x is equal to 4. Now, you can think of doing 2 different ways. You can finish solving this 2 different ways, right? You have negative 1 times x is equal to 4. You can divide both sides by negative 1, divide by negative 1, divide by negative 1. What are you going to get if you do that? Well, this is like a negative 1 divided by a negative 1. That's going to be a positive 1 times x. So it's just a positive x, and then 4 divided by negative 1 is negative 4. That's the answer. X is equal to negative 4. But if you're at this step, we chose to divide by negative 1, but you actually could multiply by negative 1 if you wanted to. If I start back over here and multiply this side, remember, I can multiply or divide by anything I want. If I multiply by negative 1, then I will again get a positive x here. If I multiply by negative 1, doing the same thing, I will get again a negative 4. So in this case, because it's a negative 1x, I can choose to either multiply by negative 1 on both sides, or divide by negative 1 on both sides, and I get to the same place because all I'm trying to do is get x by itself. You can stick this in here. 5 minus a negative 4 is the same as 5 plus 4, which is 9. And that is the final answer. All right, what about 9 minus 2 times b is equal to 3? All right, so what I have is a positive 9 right here. So I'm going to make room here. I have a positive 9. I want to get rid of that by subtracting 9, and I'll subtract 9 right here. All right, so 9 minus 9 is 0. What am I left with? Negative 2b. 3 minus 9 is -6. You should be pretty comfortable with subtracting negative numbers. If you need practice with that, go back to how we subtract negative numbers and positive numbers. Here I have something I'm going to rewrite, -2b, -6. So here I'm going to then divide by -2 because I'm multiplying by -2 here. And what's going to happen is the -2 will cancel with the -2. I will be left with just a simple b. 6 divided by 2 is 3. Negative divided by negative is positive. So I get an answer of +3, and that's the final answer. And you can check yourself, put a 3 in here. 2 times 3 is 6, and then 9 minus the 6 is 3. And so that is the correct answer. All right, and that concludes the end of solving two-step equations, part 1. I want you to pat yourself on the back because when you start this lesson, we have our little rabbit here. We started with the first little problem. Fairly simple little equation, very easy to guess that the answer is 1. 2 times 1 is 2. 2 plus 3 is 5, okay? So we can guess that. And we learn how to do the steps correctly. And then when you start getting toward the end here, I don't really care who you are. I think it's difficult to figure out what the value of b is just by looking at that. I mean, I'm not saying you can't figure it out, but the way that you would figure it out is you would say, okay, what if b is 1? Okay, what if b is 2? Okay, what if b, you're just guessing each time. And if I make the numbers larger, like if I make this, 99 and I make this -7b and I make this 138, then you can't even do that. You have to do a bunch of math on the side with the calculator. It's very hard to look at these because there's multiple steps. There's a negative sign here with the -2b. There's a lot of stuff going on, and we're not human calculators. We cannot just look at these. All right, so we have to learn the steps, and the steps are to unwrap the present. The prize is the value of that variable right in the innermost box, so to speak. And we want to get to that guy. And so we always try to take away whatever's farthest away from the variable, which is not this 2. We want to take away the 9 first. And then when we get this, then we want to take away the -2. And we want to make sure that every single step we're doing that we have learned before so we know it's legal to do it. If you feel like you're doing things that you haven't seen before, then you probably are not allowed to do it. And that just comes with practice. So practice these. Follow me on to part 2. We'll get a little more practice with solving two-step equations.